Welcome everyone to this session on creating serverless API with Azure functions. So, as part of the agenda, we will look at the Azure integration overview, then API management overview, and what are the components that are present within Azure API management, and some key concepts about API management, and how we can set the subscriptions and policies, what kind of consumption tier that Azure API management has, how do we expose these APIs, and how Azure functions can help build these APIs, and what are the benefits of Azure API management, and common scenarios and workflow and demo as well. So now I'll move into the Azure integration overview. So while in each and every project that we have looked at, so integration will play a key part in consuming the external or internal APIs with any application. So as part of it, while we are moving on to the cloud platform, we have looked at some kind of serverless compute experience wherein we can have the consistency and efficiency to connect multiple applications together. So there are different integration aspect of the integration services that we can use. So there's logic apps, wherein it's a leading integration platform as a service that we can use, wherein we can deploy and run logic apps anywhere. And scalability and portability. And as well, we can also,
can you make yourself mute? Vasudha, please go ahead.
Yeah. So we can deploy multiple workflows into a single logic app, and there are hundreds of out-of-the-box connectors that are available with logic apps which we can use. So similarly, Service Bus, where it plays as a reliable cloud messaging as a service and a simple hybrid integration platform. So we can decouple the applications from different APIs, and we can connect the existing on-premise system to cloud solutions. Then Azure API management, while we have looked at today's enterprise services are adopting API architecture to accelerate the growth. So streamlining the work across the hybrid and multi-cloud environments with a single API is the key aspect to API management. Then comes the event grid. So it's a single service to manage all the events from any source to any destination, and also designed for high availability, consistent performance, and dynamic scalability. Then Azure Functions, if we look at, it's an event-driven serverless compute platform that would help the complex orchestration problems. And we can also build and locally deploy without any additional setup. And also we can operate at a scale in cloud by using some different triggers and bindings. Similarly, Azure Data Factory, while we look at, it's a fully managed services wherein the serverless data integration service can be used, which has more than 90 built-in connectors that are available at no added cost. And it's easily, we can easily construct ETL processes, and we can also integrate this with Azure Synapse Analytics to unblock some business insights. So while we have looked at it, the main thing is, we are going to focus on Azure API management and Azure functions, because using Azure functions, we'll be creating the Azure API slip. Then looking at the complete overview on the API management, it's a fully managed Microsoft solution where we as developers can easily build the APIs and expose to internal and external applications without writing a single line of code. And the API management as part of this service, it is located in the upper layer of the backend service, and it works like a proxy. And apart from this, if we look at the distributed API management, we have a self-hosted gateway feature that expands the API management to support hybrid and multi-cloud environments, and also efficiently and securely manage these APIs hosted on on-prem and cloud from a single API management service. And coming on to API protection, so we need to transform these and then protect these APIs, which plays a key role, so that we need not expose our backend services. So rather we can hide the original URLs that appear on the body of the HTTP response. And also we can use some different policies like rate limit policy or quota policy, which we can use, which we can look at the policy slide as well on in more detail. Then the later we have a third pillar on the accelerate build apps faster, so we can build our applications through API first approach, wherein we can decouple the front end and the back end teams through API mocking, API revisioning and versioning, and also the automated API documentation also can be done. Then we also have API discoverability, wherein the Azure portal, through the Azure portal, we can directly navigate to the developer portal. And it's a fully customizable website within the developer portal, where the API consumers can discover the APIs and learn how to use them and have the automated API documentation as well. And the next is on the transforming the existing services. While we have looked at the legacy web services, those services can be automatically converted into the REST-based APIs, and that can integrate as a bridge between the backend services and the API consumers. Then securing the APIs. So how do we secure? So we can secure those APIs through a single static IP or domain. And we can protect them through different keys, tokens, or IP filterings, and then setting some different policy limits. Then coming on to API management components, so there are three different components. One is the developer portal, gateway, and Azure portal. So while we looked at the developer portal, we can read the API documentation through the developer portal. While it is a fully customizable website, we can also call the API through an interactive console, and we can create the account and subscribe to get the API keys. And we can look at the analytics on the usage and download the API definitions, and we can manage API keys as well. Then on the API gateway, this API gateway sits between the client and the service. So all the requests that are that we send from the client applications will first reach the API gateway, and then it will get forwarded to the respective backend services. While this API gateway acts as a bridge between the backend service and the API providers, it also creates an abstract of the API application, and it evolves the backend architecture.
Vasudha, we can't hear you.
No, I think she lost net. I think internet.
Okay.
Then you take over in time.
Okay, Himanshu, Lena, you want to take over?
Lena, you want to take over since Vasudha's screen is stuck? Lena, you are on mute.
Not good. I think she lost internet. So internet is lost.
Yeah, are you able to hear me now?
Yeah, I think she's back.
Yes, Vasudha.
Please go ahead, Vasudha, and share your screen as well.
Yeah, can you see my
Yeah,
screen?
I can see it. Yes. Yeah, please go ahead.
So yeah, as part of the Azure portal, the API providers, they can access the management plane, wherein we can fully access the through different Azure tools like Azure Portal, Azure PowerShell, Azure CLI, or we can also use client SDK. So these are the main components. So we will go to the key concepts while we look at it. So APIs, products, developer portal, groups, policies. So these are the main concepts that we have as part of API management. So APIs, so each API will represent a different set of operations, like you can have get, post, delete. So these are some operations that we can have as part of the API creation, wherein each API will have the backend service, which can be operated as part of the highly configurable operations that we can set through to request and respond the content, and the operation response caching can also be done. So coming to the products, so these products, so there are a couple of things as part of the products. So these products are based on how the APIs are surfaced to the developers and how it is being exposed to the developers. So there are two types. So one is open and one is protected. So open ones are freely accessible, while the protected ones will have the subscription keys that can be set up as part of each product. So either you have to delete a product or add a product, you need to have a subscription key that the third party companies or the third party teams need to access those. Then we have groups. So while we have these APIs, we will have to control them, wherein we need only certain set of people to access those APIs. Not everyone can access it. So administrator is one access, wherein the administrator will be able to manage these APIs, create these APIs, and then use it through. And we have developer APIs, wherein the authenticated developer portal users where the developers are granted access, they'll be able to use those APIs. And we have the guest access, wherein the unauthenticated developer portal users, such as the prospective customers who are there, they can be accessed only, read only on the APIs. And developer portal, we have already, I have already explained on that. So it's a native integration with Azure portal and highly customizable, where you can use the custom content on the developer portal, and any changes done on the developer portal can be easily synced to the Azure portal automatically. Then comes the policies. So as part of the API, we cannot just expose these APIs as in when it is created or it is published, right? So we need some kind of control based on the behavior of these APIs. So there are some set of sequential statements that get generated as in when we add the policies, which you can see as part of the demo. So we can easily convert these policies from XML to JSON and JSON to XML format, and also add some certain set of policies, which we'll be discussing in the next slides. Then we have subscriptions. So subscriptions are used to easily secure these APIs so that the developers can consume APIs based on the valid subscription keys by using the HTTP request. So if there is no valid key that is provided to the developers, as and when they make a request to a certain API, either it will get rejected by the API gateway, or the request will not get forwarded to the backend services. So in such a stage, so it is always better that we get the API keys generated. So we can have either primary key and secondary key, and then keep generating those APIs, so subscription keys, so that those keys can be modified frequently, and only certain set of developers who have the access can be able to send the request and get the response. Now, from the subscription part, if we look at, we can either grant the subscription keys to a single API or to the all APIs as well. So if we provide it only to a single API, then developers can access only that single API. If we provide it to the all APIs that are part of that API management instance, then the developers will be able to access all the APIs. Then apart from this, we also have something called a standalone and all access subscription. So wherein a standalone subscription, wherein so those are the subscriptions which are not associated to the developer's account. So either we can manually share those subscription keys with the developer, or we can create a custom system and make that subscription key available to the team. So those are called a standalone subscription. And all access in the sense that all the APIs, can be accessed in one API console. So that is a straightforward, wherein everyone will be able to access those APIs with all access subscription, while we don't necessarily use it at every stage. Next is the policies. So these policies are used so that we can change the behavior of the APIs by adding some configurations to the policies. So either we can convert the policies from XML to JSON, or we can use different set of policies, like while you are looking at it, the access restriction policies, we might use check HTTP header, or we can limit the call rates, in the sense that if the third party team is trying to send too many requests, we can probably limit the call rates to a particular time period. Say within 90 seconds, only 50 calls can be made in that way. So if more than 50, if there are any calls being made, then there will be the HTTP error will come up, right? So like HTTP 429, too many in that way. Then advanced policies, we have something on control flow policy and return response policies, which we can add to see whether we are getting the proper response while we are sending the request, which we can validate through the advanced policies. Similarly, authentication policies we can have either with authentication with basic or authentication with client certificate. Then caching policies we have, and coarse domain policies. Mainly it will have coarse policy, which is called as a cross origin resource sharing policy. And transformation policy, we have to transform one particular piece of code into other, like you can either convert JSON into XML or XML to JSON. Then you can opt for transformation policies. Similarly, there are DAPR policies for invoke, invoke for binding, and you can set some service for backend as well. And validation policies, say suppose if you have filled in the data for headers or queries, and then you are trying to get some parameters, then you can try to validate using the validation policies. So in this way, the various types of policies can be added to, so that we can ensure that the API behavior can be controlled using these policies, which will help the API gateway to send the proper request and response. And then the policies can be applied to change the inbound and outbound response also. In the sense, the policies will can be applied for inbound processing and outbound processing, and based on those inbound and outbound processing, the responses will hit the backend services, and from there the responses will be again taken back as part of the outbound processing to the API consumer. Then next part is on the policy access. So these policy accesses can be applied to all API at all the API level, or we can apply at the product level. So either if you go to the product module, you can see policies, or if you go to the API module, you can apply policies there, or to a single API level, you can apply the policies, and operation level. Operation in the sense, like if we have to like get, set, put, delete, like in any other APIs, while we use these operations. Similarly, these operations will be auto-created as part of the Azure functions using HTTP trigger. So while we have looked at these policies, there is an error handling mechanism also. So as and when we try to test these particular APIs, so inbound, backend, outbound, and on error is what you can see here. So the API gets triggered and executed, and any kind of errors that are seen will go to on error as part of this trace log, and we will be able to see what kind of error it is, and then try to make the So there are some kind of precautions, that we have to take as part of the Azure API management if we are trying to expose the Azure APIs. So mainly, you can apply these policies. So the first one is on the configure rate limit policy. Like I said earlier, so we can prevent the callers from issuing too many API calls in a particular time interval. So the API management supports configuring this rate limit either on the subscription or on a given value in the request. So 50 API calls can be done within 90 seconds per subscription. Right? So in that way, we can configure these rate policies and we can add these policies. Similarly, on usage quota, so might be that the policies related to usage quota might be applied in such a way that 5,000 calls within 1 GB traffic. Right? So the and within 3 hours also, we can set up the time as well for the quota policy. Then aggregation APIs. So it will combine the several requests and then the backend services, and also it will expose the front end point. So as part of this, the overall consumer experience can be improved as part of this by using a single, aggregate API that can be exposed as part of this service. Then hide operations exposed by backend services can be done by hiding the code or hiding the public API. We can hide the API operations like get, set, post. So those operations we will be able to hide, and then in such a way that developers, the external teams, will not be able to access it. Then the next one is transform HTTP headers. While we look at it, depending upon the backend service implementation, the APIs may be, it may expose the URIs pointing to some certain resources. Can be done as part of this. Then technology insights, hiding the technology insights. For we can hide the technology insights based upon the incoming request and outgoing response. So we can also do that as part of the policy, and then we can add this kind of policy. Now coming to the consumer tier. So while we have looked at the consumer tier as a pricing option, so this is entirely different, option while we look at serverless computing model, wherein we need not, look at infrastructure setup or idle capacity or high availability, automated scaling, or usage-based pricing. So all this will be, automatically taken up as part of the serverless resources as APIs. So we can, opt for this consumer tier. So that it runs on a shared infrastructure, and it can scale down zero in times of no traffic, and we can also bill it per execution. Then while we look at the Azure function, so we can use this Azure function as part of the robust development experience while we use C#, Python, PHP, or JavaScript to as well as we also have some scripting options like bash, batch, and PowerShell as well. And we also have the wide range of triggering options like HTTP trigger or timer trigger or various other trigger options are also available. Then as part of accessing and processing the data, so we can use different bindings, and these bindings will make the tasks easier. Through which we can pass different set of activities as well. And serverless execution model, we can configure this as part of the PaaS model, and then easily execute as part of the Azure function through pay-per execution billing model. And open source runtime anywhere, this can be run on Azure or in the data center as well. Then coming to the benefits, as we looked at, this Azure portal will be a common interface for API management to integrate with multiple platforms. We can secure backend services through policies, cache backend responses, and authentication and access control can be done through policies as well. And we can track the APIs for real-time errors and reporting analytics. We can use different metrics, which you can see as part of the demo. Then the common scenarios while we looked at, so these APIs, can be converted, legacy APIs can be converted into the Azure APIs without any risk or delay of migration. And API-centric application integration, so we can easily consume the APIs and then to expose and access the data or application processing. And multi-channel user experience, while we look at, we can use for web, mobile, or any IoT applications as well. And reusing these APIs will also accelerate the development and ROI. Then B2B integration, if we look at, so I mean we can also do this B2B integration as part of the self-service discovery, and then onboard and enable these APIs and download these APIs and then share it with the other teams as well. Now we'll look into the demo on how these APIs are created with Azure Functions. So we can either use Logic Apps or Container App as well, but the primary focus in this session is more on Azure App, Azure Function integration with Azure API. So I'm handing over to Lina. So Lina will be doing.
Thank you, Vasudha. Now I'm sharing my screen. See, as part of a demo workflow creation, first of all, I can create function app. Later, I will go to API management. There, I can create products, subscriptions. Later, I will create operations. There is some inbound, outbound policies is there. So I will show one by one. Before going to demo, but I will tell about the difference between Azure API and other APIs. Here, Azure API easy communication for APIs. For other APIs, enhanced security with client ID and client password. Coming to Azure API, great policies to control access, but coming to other APIs, easy to deploy API changes through automation. Now coming to Azure API, easy mock service for testing, and other APIs, good UI to manage APIs. Now I am moving to demo for that. First, I'm going to create function app. So that first I'm creating function app. First, we need to select resource group, then give some function app name. Okay. I'm selecting runtime and version and go to next tab. Here I'm defaultly it is creating one storage account. Then go to networking. I'm enabling injunction network. No, currently it is not required. I'm going to monitorings. Here I'm enabling app insights. Where this it will be created in flight ticket. Then next go to DAX review. Click on then after that we can click on create. it will take a fraction of minutes to create. So now I am not creating. I am using already existed one, which is in function app. This is the function app which I have created earlier. Now I am moving to API management. To create API management, we need to follow these steps. Create API management. Here we need to select resource group. We need to give some resource name. Organization name. Email ID. I'm selecting app insights. Here I'm selecting the app insight which I created earlier. Virtual networks, protocol settings, then tags. Currently I'm not assigning any tags now. Review and create. It will take approximately 40 minutes to create. So I'm not going this one. I am going with a already created one which I created earlier. This is the API which I have created earlier. Then go to API management. Under API management, go to APIs. Here, this is the API which I created earlier. Before going to API, first I can create products and subscriptions. Products, add product, give product name, ID name, description, and create. So it will be create the product. I have already created one product here. This is the product, flight ticket as the product which I have created earlier. Now subscription. I have already created one subscription. To create the subscription, we need to add subscription. Subscription name, display name. We need to select either all APIs, API, or product level. If all API, then it will applicable to all APIs. If API level, then we need to select particular API which we need to create this subscription key. If it is a product level, we need to select that product which is applicable this subscription keys. So then click on create. So it will be created. I have created already a subscription key which I have created. Here we will see primary key and a secondary key, which is an encrypted code. Developer can't understand this code. For security reason, it is built like that. Now go to API. First, I will show how to add API here. I have already added API, but I will show the steps how to add API. Add API, select function app, browse function app, which I created earlier. I need to select that function app here. Select it. Once we click on create, it will be created. It will take a few minutes of time. So I am not creating right now. I am using currently already I have created a earlier one. This is the API. Here we have operations. How we will get this operations means I will tell you. In API management, once we create API, go to functions, Then we need to create here create a function. We need to select HTTP trigger, then create, and we need to give function name. Then it will be create. Later we move to once we do that function, we need to go code and test. Here we can display the message. So I have created message to display. Once we click on save and test and run. Okay, see your company profile has been created. Now this in integration part, we can see the triggers. Here we have HTTP methods: get, post, delete, head, put. Currently I'm using get and post only. Now we'll go to API management. Okay, here we are seeing get and post operations. Then settings, we will see the products and the subscriptions as well here. Products we can select here. This is product I have selected, which I created earlier. This is the subscription. And
sorry to interrupt, Lina. You have 5 minutes left for the session.
Test it. We will get 2% okay. Then it is working fine. Revision and the change log here. Then go to other operation here. We have post. Then similar kind of functionality here also. Same products, subscription, user authentication. Click on test. So we will get 200% okay. And see, we have created a message got displayed here. We have created this message in function app. It has displayed here. Okay, now go to design. Select any one of the operations. Then we'll look into the inbound and outbound policies. Front end. First of all, we'll go to front end. Here we will see some front end code. In policies, I have already added
You
policies.
have 4 minutes for the session left for the session.
here I will go by limited call rate per subscription. Number 2, I am giving 60 seconds. We need to place in an inbound method, inbound tag, and click on save. Added successfully. We can add policies as well. Rate limited by key. We can add this policy. Now go to outbound. Here also we have same set of policies. We have same which I used in inbound. Same policies we can see here. Then now go to here we can go to metrics. See, we can see the metrics here. Metrics we can see by duration, back request, how many we got. Okay. Failure gateway request, we don't have any failure. And other gateway requests. Overall duration for gateway requests. Requests. This and all we can see. Now, how to download API? Here, now I am showing. We created API, right? Here we have the option to export. Once we select export, we need to select which language we need to download. I'm going with OpenAPI API using JSON format. So it will be downloaded in JSON format. Yeah, API got downloaded successfully. This is the API. Yeah, this is the API which we created. Thank you. Over to you, Latika. Do you have any questions?
Yes, I will read the questions for you. So the first question is, how do I set up multiple environments in a single API?
Latika, can you hear us?
I'll read it for you. How do I set up multiple environments in a single API?
So for this, right, you need to, I mean, like for example, if there is a test environment and a production environment, in a single API, you will have some two different options. So you can host that different API on the same tenant, or you can host the same API on a different tenant.
Thanks, Vasudha. Second question is, what routing method does API management use in deployments to multiple geographic locations?
So for this one, ideally there are these API managed the performance traffic routing method which is built in, and that will be used as part of deployment to multiple geographic locations. So incoming traffic is routed to the closest API gateway. So if one region is offline, then it is automatically routed to the next closest gateway, and in that way the routing method will work for API management.